Mm, Today's class we discuss about multi-threading in Java. So what do you mean by multi-threading? Why do we need multi-threading? Where do we use this multi-threading? That we discuss and see that the ways of creating a thread and their life cycle and the advantages and disadvantages, and we'll do hands-on in the next session. First, think about what actually the multi-threading. So it is also a programming concept, right? In which an application creates a smaller number of units to execute parallelly, which means see that if you are running a one program that is a single threaded program, okay, and the same program if you run multiple smaller units of task parallelly, then we call it as a multi-threading concept. Means it is the ability of a program or any operating system which allows user more than one user at a time without requiring any multiple copies of the program, right? Let's think about that. The same program is there, right? Now if you take MS Word, right, you have a file that is we can open the same MS Word, right? You can open another file like that. You can open n number of files from single instance, right? MS Word is one, right? You are opening multiple instances of this file, multiple copies, but you are not maintaining multiple copies installations, right? One for one, so that is not there. So here multitasks are happening, means you are not taking a copy, you are not acquiring a separate copy of that. So yeah, the thread here is a lightweight and it is a sub process, or it is the smallest unit of processing. So every thread run on its own path of execution. Why do we need this one? It is the act of executing a complex process using virtual process independent of each other. So we call this or as multi-threads, means these are all threads, means so from a single resource, from a single program, right, you can have n number of processes that are running independent of each other without knowing of each thread. Yes, make sure a thread is running, then it will not interfere other thread. Every thread have its own path of execution. But threads are not physically exist, they are virtual, which means they create whenever the request is there for the thread, and they will go live, they will terminate that thread once the current request is done. So that is called, we say these are virtual tasks, means virtually the threads are created, and once they finish that job, then their life cycle is dead. Means again it has to starts with a new request to create a new thread and go ahead. Here one important thing is thread share the same memory location, because they will not create any new memory. Let's know if pool of threads are there, so pool of threads means n number of threads, then they will share the same memory location of this process where the process is created. If a process is acquired with some memory, allocated with some memory, the threads will not have another type of memory. They will share the same memory location where the process is created. So this way you can save memory, you can save time, because of you are running multiple copies, multiple tasks of this single program without additional space or additional memory, and you will be able to do your tasks quite faster. What is this advantage? It will not block the user because the multiple threads are independent. As we see the as you are consuming one process, right? Let's take an example of online banking. As we are in some hundreds, thousands, lakhs of customers are there to every bank, right? Let's take an ICICI bank, some lakhs of customers are there. Everyone is using the system to log in, right? To check their, to do their transactions. So it's not blocking any user, right? So other user is already logged into the system. You have to wait for that user until that user has come out. No, it is not blocking your task. You still go ahead with your transactions because you have your own credentials. Then why do it should allow, it should block your work? It should not. So how it is happening, the same application as some n number of users using, how this is happening? Because of a separate and independent thread is creating for every request, even though application is same, right? Depend on the user request, the separate thread we create for him to go ahead with his work or task. So like that you can perform many operations together like this, you get, so that it saves time also, right? Threads are all completely independent. When you are working on the system, so other guys also working on the system, this thread will not know about that thread. But you can monitor how many threads are running. We can programmatically see that how many threads are created and who are all working on the system. It does not affect any other thread. If something happens in your thread, for example, now when your thread is running, right, if something goes wrong with your current thread, if any exception comes, right, it just halt your execution so that it will not eh, interrupt or disturb other thread execution, because every thread is working on its own memory virtual path, right? So it does not know about each of these thread. If this thread is running successfully, right, if this thread throws an exception, it doesn't matter. Each thread have its own path of execution, right? So this is how thread. If you look at the cell life cycle of thread, this is what about the life cycle of thread. The first time, right, it is a new thread and runnable when you start this method and running blocked. Then finally it go to dead state. It is not meant to say that after all doing this it go to dead state. So from new state you can directly stop and it go to dead state, which means if the thread is not in a running mode, then we call it as a dead thread. Right, from new we can directly do that. If it is from the running, right, immediately you can terminate that. How do that? Using with the help of these methods, we'll discuss in detail. Let's see this one. See the new state. First one is the new state. New state in the sense what? When we create a thread object using a thread class. So there are two different ways that we create a thread object. How do that? You by extending the thread class and by implementing the runnable interface. So extending the thread class is nothing but you will acquire this automatically. The thread class gets implement this runnable interface. If you see that one, for example, now we have a call multi-threading. Thus it is extending the thread class now. If you go here, it implements the runnable. In runnable, have the method run. So this is one way of creating a thread. Another is directly implementing that runnable interface, which we seen here. This guy is extending this and implementing the runnable interface. So we can directly take this runnable interface and implement this, which is a functional interface, which means have only one abstract method. So this is way how we can create threads in two different ways. One is extending the thread class and implementing the runnable interface. But what is the advantage of why we need two ways of creating threads? Okay, let's see now. First, now if extending a thread class, what happens now in Java, multiple inheritance will not be supported. For example, now I extended something. Okay, let's say I extend something like Java, sorry, Java access modifier. I extended this class due to some reason to extend the parent functionality. So at the same time, my class wants to extend the thread functionality also. If I say comma thread, right, it will not allow. You could see this, you get exception syntax, right? In Java, multiple inheritance will not be supported. If you extend any one class, then it will not be allowed to extend another class, right? Extending of thread class, right? And again, it will not let you to extend another class. So due to that restriction, we are implementing the runnable interface, right? If you implement the runnable interface, right? For example, let's say implementing the runnable thread. Here we have implement the runnable interface, and then I can extend. Sorry, first extend should be the first thing. I extend this one. I extend what happened? What I extend then? I will extend Java access modifiers, right? And then also implements runnable interface, which means my class extending one class and also implementing the interfaces. Even you can implement any other interfaces also if you have multiple interfaces. This way you can achieve, right, by implementing the interfaces and extending other class. So this is the difference of that. If make sure if your class does not want to extend another class, then you go for thread class directly. Or else if you want to extend, if you want your class extend another class, then you can implement the runnable interface. But if you implement the runnable interface, then while creating a thread, right, when you before you start the thread, you have to have one additional small piece of code difference that we see that in the next lecture. Now discuss about the thread life cycle state. What is it? It's the first state. It is a new state, which is a newborn state, means the thread is born. When we create a thread object using a thread class, then the thread is born and we can say it is in the born state. So that is when the thread is born means then it enters into the new state, but before it actually call the start method on the particular instance. And otherwise we can say the thread object exists, but it cannot execute any more statements because it is not in the context of thread execution. Whenever we call the start method, the new thread will get changed to inverse. Otherwise, we can see what we see, this illegal state exception will be thrown. Means the state is not in the proper, right? So when do we say this thread is exactly new, right? Let's for example now here I extend a thread and I'm going to create the object of this thread. Now, what's happened? Then I create a thread, but this is the thread is born, means your thread is born. You will not yet call the start method. Okay, I will explain in detail about the program. No worry. Okay, when I create a thread, which means you have created the instance of the thread, but on that thread instance, you have not called the start method. Then that is called a newborn state or new state. And what is the next thing is runnable. When the moment you start the call the start method, means when start method is called on a new thread, right? The moment you say thread dot start, then it enters into the runnable state, right? So that is called a runnable, means about to run. It actually not running, it is about to run. There is a one more state which is a running. So when this running, and do we need to call one separate method run? No. Internally, if you look that when you call the start method of this thread object using the thread dot start, what happens that start is create a separate call stack for the thread, means the JVM do this for us. Okay, we do this one. The moment we call the from the program, if you call the start method of the threaded class, right, it create a call stack for the thread, and a separate call stack is created by and the run method is called by the JVM. So internally it calls that. You don't need to call explicitly. If you call explicitly, right, then there is no point. Means your threads are not running. That we see the difference of that calling the run method and calling the start method. So when you say start, right, the thread is in the runnable about to run, then the JVM will automatically create the run method for you to go ahead to run your thread. Okay, when the moment you start means just a start, means the moment, see, soon after you the threads method start is called, it enters into runnable state, but it is not yet to running. It's supposed to run. Who do that? When the JVM calls that method run, right, then your job will run into execution mode, means running state. So in runnable state, the thread is ready for execution and is waiting for the availability of the processor. Availability of the processor is in what? See, in the CPU, right? All these threads and processor are utilizing the CPU space, right? CPU time. So the CPU has to decide the any process is available to give this thread to run. Otherwise, right, if just going ahead calling the run method, then just say exception, right? What is that exception? This, right? Thread not found, or an object is not found. So some kind of exceptions are there, means illegal thread like that. So first the CPU checks the availability of the process, means before you run, the thread is waiting in the queue, so someone is waiting in the queue. So let me check the process that is available for this thread to run. Once the process CPU allocates time slot for the thread execution, right, then it enters into the running state. So what this happens on this, how the CPU is allocating the process, right? Or if we have n number of threads in the queue, that all the threads have some priority. So CPU allocates the slots for each thread execution on the basis of first come first serve manner. Because if you have n number of the threads that keep calling that, whoever come first, then for that, then it will allocate the process. It is like, it is called as time slicing. Time slicing nothing but allocating the process of allocating the times to threads is known as, is called as time slicing. So when this thread comes into runnable state, a thread can come into runnable state from even from the running state or waiting or new state also, right? As you see this runnable state, right? Okay. From the new, you can go to runnable state, and from running also you can say it's a runnable state. Now go for the next thing, running. As told you, just when this enter into running state, running means that then you have the CPU. CPU is allocated some process to execute your thread. So when the thread scheduler start, then it changes from runnable state for execution. So when it is executing means then the thread is running. It is going to running state. So in the during running state, the processes gives its time to the thread for execution and execute its run method. Means the moment it enters into this running state from runnable, then it start executing and finish this task. So this is where the thread perform its actual function, means during running state only it perform its actual task, means what been implemented in the program, right? What logic, what piece of logic we have to run using threads, that will happening during this state. Okay. It now from the running state, you can change the thread to some different state. What thread side? You can see this when the thread is running, then you can suspend the thread and you can make the thread wait, or you can sleep the thread. How this happens, right? There's some certain situations, right? If any, if a running thread is running, and if some task that need to execute after a certain period of 1 second, 2 second, right, then we can go with the sleep method, right? Please wait for some specified number of milliseconds, then resume this job for every task, right? Then it go there, then you save a sleep method, then it go to the runnable method, then from the runnable method again, once the sleep time is in work, then again come back to the running method. Again you can suspend, you can make the thread wait. Wait means then it wait for until the other thread execution is happening. That so when sleep method is invoked on the thread, what happened? It sleep for a specified milliseconds. We're not passing the minutes, hours. It accepts only milliseconds. So again, when that timeout occurs, the thread re-enters into the runnable state as soon as this time period is lapsed, and then going to the running state. From runnable means again automatically from there it move back to the running state. What happens when this thread is suspended? So what is suspended? So when we thread is suspended using a suspend method, means we are saying that suspend for some time, right? Which means there is some condition that we are checking, that to meet that criteria, to satisfy that conditions, a suspended thread can be reviewed by resume method. Means a thread should be suspended for some time. So how do you invoke that suspended thread? We have to have a method, suspend resume, right? Fast resume. However we have this, right, to fast and resume the videos. Same way that have the method called for suspend jobs to resume. We have a method called resume job. Means then when the condition is satisfied, then the suspended thread will move from the suspend to the resume, then it will go ahead with the running state. Then what is the use of made method? Made method also same thing. That's it wait for some time, but not known how much time it is that one. If you see this one, first thing sleep is we are specifying the number of milliseconds, right? We know once it is completed, then you no need to explicitly say that go and running. Soon after the time is lapsed, then automatically it will go ahead with the next step. If you think about this suspend, right, until it meets the criteria, until it satisfies the condition, then the thread will be suspended. But here the wait method, it does not know how much time the thread has to wait. The thread has to wait until, right, some other thread is executing in the monitor. For example, if some one thread that is executing the same monitor and you are there waiting for the same monitor to enter into the monitor to do job, so you have to wait until the thread inside the monitor has to complete that. Once it completes and come out, then the thread will notify, hey guy, I am done with my task, and I will say the next waiting thread will be notified so that it will enter into the monitor. So this is all the difference about the suspend, wait, and sleep method. Sleep we cannot control. Means once the time is elapsed, then it automatically next change its state. And suspend it because of some conditions. And notify, it is applicable to the monitor. When one thread is executing inside the monitor, right? Then other thread which is outside in the queue will wait until that current thread has to come out. Soon after it comes, it has to invoke the method notify on the current thread. Means what is notifying means I am done with my job. Whoever is waiting in the queue, please move ahead, go ahead with your task, so that the next waiting thread will enter into the monitor to do that job. This is called about the running state. Now we see block state also happen. When do the block state has happened? If you see this, the block state is nothing but after running that idle. If the thread is idle and not running, then we call it as a block state. Means when it is in thread is considered to be the block state when it is suspended or sleep, waiting, or sometime in order to satisfy condition. Means I'm blocking my thread, okay, to wait some time. So when it is running, then if you use all these methods, this guy gets blocked, then come back to that. So there are other situations where the thread may be blocked, or for example, in the real-time scenario, right, if you have a number of threads requests are there, but all the threads cannot be entered into the same monitor. All the threads will be wait in the queue. So due to some exception, if the thread which is running in the current monitor, right, which is currently running, is not come after a long time also. What's happened is all these threads keep waiting, said it may good chance of going to the block state, and right here deadlock also will happen. Now what is the deadlock? This guy which is opening outside, right, waiting outside and front to the monitor, and the other guy is waiting for this guy, means both the threads are waiting for each other, right? Then they are not able to complete their task even after a long time. So waiting for each other, this guy has to come, then I to before I enter, and that guy is waiting, this guy has to come before I enter. So both are waiting for each other, both the threads are waiting for each other before they perform the actual task. So that case, the threads will never complete and will not come out of the current state, and it go to dead state. Sorry, it go to block state. That is called as a deadlock. Means it is completely locked. It is the threads will never again resume again automatically until unless we go and kill the current threads. Means we have to remove that, we have to restart application, or we have to kill those threads from the processor, from outside of the application. Those we call it as a deadlock. Means the thread is locked completely, so no other threads will never execute these things. Okay, now what is the last state? Is the dead state. What is the dead state? Means a thread made that because of several reasons, right? When its run method completes execution, right? After this run method's complete execution means when is running is completed, then, right? Which means once it performs its task, once it is completed its task, right? Then you can go to that state, which means I'm done with my job, right? For example, during runnable state also, right? If someone ill, right? Then someone directly can stop this, so it go to runnable state, dead state, which means that if the thread is terminated or dead when the thread comes out of method, or method can be dead when the stop method is called. For example, now in real time scenario, right? If there is somewhere during running, right, or maybe runnable state, right? If something happens, if any exception happens, and you want to stop the thread to be terminated, what happens then? You go and call the stop method explicitly, which means say stop the current running thread. So you don't want to continue that thread to be executed because of some exception. If exception happened, right, then I don't want to move ahead with this error process. So then you call them stop method explicitly. During the life cycle of thread, so the threads keep moving from one state to another state in variety of ways, right? So we cannot say this goes from here to here, here, depend on the logic that we have implemented, depending on the methods and depending on the requirements, we are maintaining the states of the thread. Threads is not automatically changing the states, right? When did do automatically changing state? If the thread successfully running all its stuff from start new to runnable to running, then if there is no exception running, right, then automatically changing its state from all this 1 to 2, right, like new to runnable to running, from running to dead state, means the thread successfully completed its task. So this is all about the different states of threads. Now, as we talked about, there are two different ways of creating threads, right? Extending the thread class and runnable implements. And there is interview question that is asked that how many ways we create threads? We can simply say there are two ways, by extending the thread class and in implementing the runnable interface. So this is the answer. This is the answer that everybody says that. But what is the difference? Why, if we have two different ways of creating thread, why do we need two different ways, and which one is better? Then there is no answer. If you already know the inheritance concept, right, then you can easily answer to this question. Extending the thread class, right, it is not the efficient way. If we're, but we can, that is also better, but depend on the requirement, we can say which one is better is the thing, but right, everyone is saying implementing the runnable interfaces only, right? Extending the thread class means now if your program wants to acquire all the methods in the thread class, right, then you go for the extending the thread class. When do you implement the runnable interface? If you want that only one run method and you don't want a complex uses of thread in your class, then we go for runnable interface. It is not meant to say that, and because of not supporting multiple inheritance, not only multiple inheritance, unnecessarily extending the thread means all the properties, right, all the behavior of the parent, you just blindly extending that. If you don't want this all this functionality, why you need all this, right? You don't want all this stuff in your class, so you, that reason, right, that situation, you can directly implement the runnable interface. Your intention is that you need to have this one run method. My requirement is just to start my thread and run this run method, right? So this is again depend on our requirement only, right? This is second thing. First thing is it is not supporting multiple inheritance, okay, that is straightforward. And second thing is depend on the requirement. If you don't want the complex uses of threads, then we can go with the runnable interface. Or if you want to have complex logics in the current program use extending thread, then you go for extending of threads. So simple answer, we can say that some most of the freshers saying that extending thread is not feasible as it will not let you to extend another class. That is one example. Another thing is depend on the requirement also, right? Say mostly we are implementing the runnable interfaces only, so to run this, so that is the reason it is more efficient way of creating thread by implementing a runnable interface. This is the right choice for right, that interview guy.